Today's preparation is about cost-benefit analysis. Before we get started, an announcement. I want to mention that the syllabus is being updated based on some schedule changes, and also problem 6 on lab 3, I'm making this portion extra credit. So if you turn that in as part of your lab report, you'll all get some extra credit for it. I mentioned in the syllabus that this sort of extra credit is used to offset missing assignments, that sort of thing. So it'll be worth about one missing assignment, or a portion of a future lab if you had to miss or something like that. Okay, benefit cost analysis. It's often used when you're judging municipal projects. The idea is that you take all the benefits that come from the project and all the costs that come from the project, and you take the ratio of those two things, and if the ratio is greater than or equal to 1, then it's worth doing the project. So benefits and costs, note that they're accruing to different parties usually. Often maybe like a city will be paying the costs, and the people who live in the city will be reaping the benefits. So that's why we say they accrue to different parties. So the benefits on top here is the sum of any receipts that come from it. This can sometimes be intangible factors that have been given a monetary value, like happiness potentially, but maybe it can also be like, let's say that you're building a bridge and it's going to save people, or an extra highway, it's going to save people time. What's the positive economic impact of that decision? So you can see how there could be benefits that have a monetary value to the users of a large capital project. You can also have disbenefits. So let's say that this highway had a toll. That would be a disbenefit by the project users. Now, the costs are assumed to all be incurred by the project initiators. We treat those, all receipts, any of the good things that are happening, we treat those as positive. We treat all the costs as positive as well, too. Any disbenefits, costs that are incurred by the users of the project, we treat those as negative. And we treat those ones in the numerator, and we treat true costs by the project initiators in the denominator. So be careful where you put things. And we'll see in an example how you can make a choice for where things go, whether it's a disbenefit or a cost. Note that you also need incremental analysis in order to compare alternatives. You can't just say the benefit cost ratio is better for option A than option B, therefore we should go with option A. You should do an incremental analysis, meaning you should take the difference between the benefits of the two different things and the difference between the costs of the two different options, and assess whether that's greater than or equal to 1. If you've got more than 2 alternatives to consider, then you take all the pairwise differences and compare all of them. So, as an example, we're building a bridge over a big ravine, and the State Department of Transportation can shorten the time it takes to drive through a mountainous area, right? Estimates of costs and benefits, due to decreased travel time, fewer accidents, reduced gas usage, etc., have already been prepared for you. So we already know the net present value of all these things. Typically, maybe on the FE exam, you might have to calculate the net present value for the costs and benefits, but for this one, they've already been calculated for us. And they're tabulated here. We've got the NPV of the initial cost is $40 million. The capitalized cost, which is the net present value of all infinitely far into the future annual maintenance costs, $12 million. All the tolls that the people who drive on the road have to pay, $1 million of the capitalized cost. The capitalized value of the annual user benefits, any saved gas, decreased travel time, fewer accidents, etc., that's valued at $70 million. And there's no residual value at the end of the bridge's life, so it's not going to be sold for anything. Should the bridge be built? That's our question, so let's go ahead and assess this using benefit cost analysis. Okay, so our formula for benefit cost is we need to take the sum of the benefits, and we're going to divide by the sum of the costs. Okay, and so what are our benefits in this case? Well, initial cost certainly isn't one of them. because that's something that has to be paid by somebody. That's never going to be a benefit. Capitalized cost of annual maintenance. No, that's another cost that also has to be paid by somebody. Capitalized cost of tolls. That's not going to be a positive benefit, but it is something that's done by the user. We'll come back to that in a second. Capitalized value of annual user benefits. That is certainly a benefit. So we've got 70. Disbenefits. So these are not incurred by the sponsor of the project, the initiator of the project. They're basically negative benefits, things that the users of the project have to pay. And in that case, we have the capitalized cost of the tolls. So we've got $1 million in disbenefits. And then the true costs, so in order to get the sum of the benefits, then we take the sum of all the benefits that we have. We might have more than one. We might have multiple disbenefits. We sum all the benefits up and we subtract all the disbenefits. So we've got, in this case, 70 minus 1 is $69 million. And let's take a look at the costs. Well, we've got an initial cost of 40 million. We've also got 12 million capitalized cost. And we've already treated the capitalized cost of the tolls as a disbenefit, not a cost, because it was incurred by the users of the project, not the initiators of the project. And the capitalized value of annual user benefits, we don't include that there. Any residual value, this was 0. So that might go as a benefit, perhaps. If it were non-zero, it wouldn't be a cost. Or I suppose it could be treated either way, maybe a negative cost at the end, but typically that's not something that you're going to see and have to make a choice for. So we sum those up, and that is 52. All right, so the sum of the benefits over the sum of the costs is equal to 69 divided by 52. Calculate that out, and we get 1.33. And this here is greater than 1, so that means yes, the bridge should be built. So then you also might have a second option. So here we've got a second option for the bridge has been prepared. Looks like a revised estimate of the capitalized value of the annual user benefits is 68. So we'll have to take that into account. And let's continue. Which option is preferable according to benefit cost analysis? So let's try that one. Okay, so the sum of the benefits of option A, let's do option A, and we'll sum the benefits up. We'll do option, we'll sum the costs up as well, and we'll also do option B. And then we have to do a difference between the two. So a third option, a fictitious option, I'll call it delta. And it's going to be the difference between the two. Okay, so the sum of the benefits for option A, well, we've got this 68 minus this disbenefit of 1, so that'll be 67. The sum of the costs for option A is 40 plus 12 is 52. Option B, we've got the sum of the benefits is 68 minus those capitalized costs, the tolls. So we're going to have 64.5. And the sum of the costs, 35 plus 15, that's just going to be 50. And the delta is going to be the difference between the two. So we're going to take 67 minus 64.5, that's going to be 2.5. And 52 minus 50 is 2. So the sum of the benefits of option A minus the sum of the benefits of option B over the sum of the costs of option A minus the sum of the costs of option B is 2.5 over 2 is equal to 1.25. And that there is greater than or equal to 1, so option A is preferable.